Hello students, I am Sailesh Prajapati. Today I explain you chapter number 3 matrices in the remaining questions for exercise 3 and some miscellaneous examples. So in the question number 12, exercise 3, if A and B are square matrix and also given AB is equal to BA, then prove that by principle of mathematical induction A B raised to n is equal to B raised to n into A, and further prove A B raised to n is equal to A raised to n B raised to n. So very easy students, here I will start first. These two are the given and that's are the proving. So here I will go to our question in the P of n, principle of mathematical inductions. It is A B raised to n is a B raised to n A raised for n belongs to natural. And in this parts we start first step 1. So my step 1, if n is equal to 1. So what is your LHS? That's your LHS. P of n will do P of 1. It is AB raised to n, AB raised to 1, and RHS, which is B raised to n into A. So B raised to 1 into A. Check both are same. Therefore LHS is equal to RHS if I told these are the given. Yes, from given AB is equal to B, and that's your simple first step is done here. Now I will moving towards our step number 2, and that step number 2 is if PK is true taking and apply PK plus 1 is true for the further proving. Now students, we start our step 2. So if PK is true, so you just apply our this P of n, write down in P of k, AB raised to k, which is B raised to k into A for k belongs to natural. And the step 3, which is to prove P of k plus 1, just you can write down in place of k, k plus 1. So AB raised to k plus 1, B raised to k plus 1 into A, and now I will start my LHS. AB raised to k plus 1. You will just write down using these steps. So here AB raised to k into B, because base same, power 80 subtractions, and this AB raised to k I know that from step 2, B raised to k into A into B, here mentioned from step 2. And these are the both joining because A and B are square matrix. So this AB and BA is given. So I just write down here BA, because AB is equal to BA. Now this both you joined by the square matrix B raised to k with B raised to 1 into A will do k plus 1 into A, and that's your students RHS. It means your step 3 done. So I just write down here after that, therefore P of k plus 1 is true. In shortly taking a last step, if PK is true, then P of k plus 1 is also true, and that is your easily first proving is done. So I will write down by PMI, Pn is true for every where n belongs to natural. Now further proving this one, AB raised to n is equal to A raised to n, B raised to n. So I again start, yes, also we will take, we prove this one, AB raised to n is A raised to n, B raised to n. So here you will take your P of n of principle of parts a raised to n in the b raised to n. That is my now second principles. But using this amount, using this value, I will show that. So same doing, step 1. If n is equal to 1, what the LHS? ab raised to n, which is ab raised to 1, and RHS same as, you will write a raised to n, b raised to n. So a raised to 1, b raised to 1, it is same ab. It means LHS is equal to RHS. Confirm they are same. So we will check P1 is true. That the first done. Now going to step 2. Our step 2 is if Pk is true. So your data, you will write down this P of n in P of k. ab raised to k is equal to a raised to k, b raised to k for k natural number. And my step 3, which is to prove going that P of k plus 1. So apply k is k plus 1. So here ab in place of k, we write down k plus 1, a raised to k plus 1, b raised to k plus 1. This proofing internal, I will use this data because already given in the questions, and start this simple way solutions. So I just start my LHS. In the LHS, this one, ab raised to k plus 1. Here also you will write down ab the k power and ab the 1 power. And now ab raised to k power, you know, according to step 2. Yes, it is a raised to k, b raised to k, here a and b, and mention from step 2. Now our target is proving a raised to k plus 1 when they exist. A raised to k and a raised to 1, these two are the merge. But before going, you just check ab raised to k is known. So here just I will write down the two terms are joining, b raised to k into a. So a raised to k separate, b raised to k into a separate b, because a and b are square matrix. That's why we will write down that. And b raised to k into a known. Yes, it is ab raised to k. What that? It is ab raised to k into b, because from given ab raised to k is equal to b raised to k into a, that using, now here you will separate the both like terms, because again a and b are square matrix. So this and this are the both bunch. That's the proofing. So a raised to k plus 1, b raised to k plus 1, that is your RHS. So here finally done, p of k plus 1 is true. So if pk is true, then p of k plus 1 is true. So here also you will say by PMI, principle of mathematical induction, that is the proof. Pn is true for n belongs to natural number. And here your second data is also proved by the PMI. Now I will continue my question number 13 in the MCQs. That is the easy now, but in MCQ is asking questions over. If the matrix A given and also A square is equal to I, if A alpha beta gamma minus alpha is such that a square is equal to I, then only option asking. My first option is I plus alpha square beta gamma is equal to 0. Second, it is a 1 given, not I, my mistakes. 1 minus alpha square beta gamma 0. Third, minus alpha square beta gamma 0. And last option D. So students, here only I use a square is equal to I and apply a into a. These are the I will apply a square is equal to I. It means a into a. But a I known, alpha beta gamma minus alpha, same alpha beta gamma minus alpha, and I also known 1 0 0 1. Here students, I will do matrix multiplications, this versus that. So your data is alpha square beta gamma. Now gamma alpha minus alpha gamma, but they cancel. Same alpha beta minus beta alpha, this also cancel. And last gamma beta plus alpha square, and here same is this cancel. You have to only one like term equality and they get the students simple answers. So remaining are alpha square beta gamma 0, here also alpha square beta gamma 1 0 0, and make the equality. So what you get, alpha square plus beta gamma equal to 1, so that's your answer cover. 1 minus alpha square minus beta gamma, you just check where is your answer. 1 minus alpha square minus beta gamma, option is purely C. Now moving towards question number 14. In the 14, if the matrix A is both means symmetric and skew symmetric. If the matrix A is both symmetric and a skew symmetric, then asking what is the options. My options is, first given students, A is a diagonal matrix. Second, A is zero matrix. Third, A is square matrix. And last, none of this. So students, here if a matrix is symmetric and skew symmetric, both definition you know. Yes, if A is symmetric and skew symmetric matrix, definitely you will cover to, if you symmetric, the transpose is A, and here transpose is minus A. Both you compare, A is equal to minus A, 2A is equal to 0, A is equal to 0 matrix. Your data is done. Simple. Yes, here you are done easily. Now I will cover to 15th one. Very easy MCQs. Now in 15, A is a square matrix. 15 is IMP questions, students. If A is square matrix such that A square is equal to A, and then I plus A the cube minus 7A is equal to dash 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 dash. So your data is a capital A, I minus A, I in 3. Students, are clearly given a square is equal to a. This is another word also using in exam. It is a idempotent law. Again repeat, idempotent law. A square is equal to a. Definitely you will write down a cube. Is a square into a. Will do a into a. A square. This again a. If you are to 4, calculate this also a. So now I will cover to I plus a the cube minus 7. Here apply whole raised to cube. A cube plus b cube plus 3ab a plus b, that is I a and I plus a. These are multiply inside. Very easy. Here I cube is definitely a cube also I calculate, it is the a, and that two are the, it is a 3a. I is identity 1001, yes, into a, that is a I plus a minus 7a. So I plus a plus, these are multiply, 3ai plus 3a into a square minus 7a. Now this a square again use, it is the I. So I plus this also multiply, 3i, it is a 3a, this also 3a minus 7a. This totally 3, 3, 6 and 7a. So I plus 7a minus 7a, which is exactly I, and that's your simple to simple answer, students. And here our exercise is done, students. Now I will start my miscellaneous examples 26, 27 and 28. Very easy. In the miscellaneous example 26, prove by PMI. Yes, it is a PMI asking. Example 26. To prove by PMI a raised to n is equal to cos n theta minus sin n theta, continue, sin n theta cos n theta, and belong natural if a is given cos sin minus sin cos n theta sin n theta minus sin n cos n theta, cos sin and minus sin cos. A raised to n, we will apply that it is your p of n. This you will check p of n and start your PMI rule. Step 1, if n become 1 taking. Simple. So LHS p of n will do p of 1, which is a raised to n. I will write down a raised to 1. That's your LHS. And my RHS, this your RHS. Sorry, this one. Cos n theta minus sin n theta, continue, sin n theta cos n theta. You just apply, n is become 1. So it is cos theta minus sin theta cos theta. Check, it is a definitely, that's RHS. It means both the same. So confirm, we will take LHS is equal to RHS. It means your P1 is true. Now I start my second steps. Step number 2. To going ahead very easily. In step 2, if pk is true, so you just show your this p of n will cover into p of k. I mean a raised to k cos k theta minus sin k theta. Continue, sin k theta cos k theta. for k belongs to natural. And step 3, which is to prove p of k plus 1. So whenever your k, write down in place of k plus 1. So a raised to k plus 1 cos k plus 1 theta minus sin k plus 1 theta sin k plus 1 theta and cos k plus 1 theta. That's my target. Now LHS. A raised to k plus 1, a raised to k into a raised to 1. This a raised to k, it is used the step number 2. A is given. Both apply and multiply. So your data is covered. A raised to k cos k theta minus sin k theta sin k theta cos k theta into a become this one cos sin minus sin cos and apply by matrix multiplications. But you pushing down your value from pk is true. I will write down this value. Now matrix multiply. Yes, it's very carefully we write down now. Cos k theta with sin k theta. Same is minus sin k theta cos k theta. Column 2 time right. So continue. Cos k theta sin k theta and last minus sin k theta plus cos k theta, and you apply the value. First column value cos and minus sin. Here cos theta minus sin theta, cos theta minus sin theta. Same as sin cos. Here do sin cos, similarly sin cos. Indirectly, this is the formula of that. Yes. So you will write down directly from that cos k plus 1 theta. Next minus sin k plus 1 theta. This answer is same as that. Next sin k plus 1 theta and last cos k plus 1 theta. And that is your, you will show RHS. It means pk plus 1 is true. Therefore, we will write down p of k plus 1 is true. So, if pn is true, I mean pk is true, then p of k plus 1 is also true. And last write down at the end of this sum by PMI, this pn is true for every and belongs to natural number. Now continue. Example 27. Very easy and interesting numerical. 27. If A and B are symmetric, question is A and B are symmetric matrices of the same order. Then show that, yes, the question is show that AB is symmetric if and only if A and B commute, it means both, that is AB is equal to BA. So this is very simple. Our target is a symmetric proofing. So transpose tech is equal to same. Yes, A and B are symmetric first of all. This definition I will attach here. If A and B are symmetric matrix, It means A transpose is A, B transpose is B, and my target is this also symmetric AB. So we start now. AB the transpose, formula known, B transpose A transpose, but B transpose is also known, it is B, that is A, because write down B transpose is B, and now BA is equal to AB given from AB is equal to BA. Finally you will cover AB transpose is equal to AB. So what you tell? So AB is symmetric matrix, and that's the cover, your simple way, your answers. Now example 28. 28 is the most IMP for exam level. This is the last example in your miscellaneous series. Now into 28, same as, let A, B and C given, find the matrix D such that CD minus AB is equal to 0. Example 28. Let A matrix 2 3 minus 1 4, B 5 2 7 4, and C 2 5 3 8. Find matrix D such that CD minus AB is equal to 0 matrix. Students, here A, B and C are 2 cross 2 matrix given. So D suggests 2 cross 2. Suppose D matrix will do ABCD in the 2 cross 2 and apply that CD minus AB is equal to 0. So CD is equal to AB. Apply the C matrix, D matrix, A matrix and B matrix. See, I have 2 5 3 8. Now D is also unknown, the ABCD. A I have 2 3 minus 1 4, and the B last 5 2 7 4. Here just you can do our matrix multiplicative rule. Yes students. So here 2 with bracket, 5 with bracket, same as 3 with bracket, 8 with bracket, 2 with 5 and 3 with 8 is equal to this side also same, 2 minus 1 3 4, same as students, 2 minus 1 3 4, and apply the value here AC. Next AC. Similarly students, BD in this side 5 7 5 7 and the 2 4 2 4. Finally you will cover one the little equations, and simple way they cover to your equation solutions. So just simply you added the parts one by one. Here twice A plus 5C, 3A, 8C. Similarly 2B plus 5D and 3B plus 8D. And this way your 10 minus 7, 3. You have 15 and 7 4s are 28. 8 5 and 3 33, 1 43. Yes, 8 and 5 13, 1 carry, 2 3 and 4 43. This side also same, 2 to the 4 and 4 0, and last 3 to the 6 and 4 4 the 16. They are the 22. 4 4 the 16 and 3 to the 6. Yes, it is a 22. Now you just make the equality. So by equal matrix 2a plus 5c. We'll do 3. Statement 1. 3a plus 8c. 43. Statement 2. And another way, 2b plus 5d is 0. Statement 3. And 3b plus 8d is 22. Statement 4. This and that are eliminated. Yes, this I calculate. Solve 1 and 2. Here do 3 multiply. So here do 2 multiply. Here 6a. 5 3 is 15. 3 3 is 9. Here 2 multiply, then 6a. 16c, and here 2 multiply means 3 to the 6 and 4 to the 8. This cancel. Here minus c only. And 86 minus 9. Here 7 and 10. 16 minus 9. It is because 7. That is 77. Yes, just tally. 16 1. Correct. So your c become 77. And this c outline and even a defined. So from 1, it is 2a plus 5c. 5. C becomes 77. And just multiply. Simple total. 7 5s are 35. 3 carry. 7 5s are 35. 36, 37, 38. So 2a equal to 3 minus 3 out of 5. We'll do minus 3. 85. A are 82. So a become minus 382 by 2. And it is cancellations. 19 2s are 38. And 1s are. A become minus 191. Yes, A known minus 191 and C is a 77. Now I will calculate the further B and D. Same as these two are evaluate. So solve 3 and 4th. So these are the multiply 3 and 2 simple way. 3 multiply then 6b. 3 5s are 15d. 0. And here 2 multiply 6b. Here 16d. And here 2 multiply then 44. Again 3 to the 6. 5 3 is a 15. 2 multiply 6. 16 and 44. This cancel. Minus d. Minus 44. D become 44. And I'll go to simple third. From 3. Here ending your sum, 2b plus 5d is 0. So 2b is equal to minus 5d. So 2b is equal to minus 5. D I have 44. So minus 5 into 44 by 2. We'll do 22. And 22 5s are. Yes, 110. So finally this B also done. So required matrix D, A, B, C, D. Your A is a minus 191. B become minus 110. C is a 77. And D is a 44. Yes, I just checked my answers. Minus 191, minus 110, 77 and 44. Students, here our this exercise examples done here. And students, our chapter is also done. And students, here I stop my video. And further explanations we going ahead in the new chapter. It is a determinant, chapter number 4. Okay students, bye bye.